Hello and welcome to the Digital Spiffy YouTube channel. This video is the fifth in a series covering the material on the CCNP ENCOR exam. I will be using GNS3 with Cisco CML licensing to lab the material. The lab material is sourced from the CCNP ENCOR Lab Manual version 8. I highly recommend reading the CCNP Enterprise Core 350-401 official cert guide in conjunction with this lab material. This will provide a better understanding of the labs and what is occurring on the equipment. You can find links to these books in the description below. This video will cover the VLAN trunking protocol and how Vtp assists with provisioning VLANs and ensuring that switch-to-switch connectivity can carry multiple VLANs. Cisco created the proprietary protocol Vtp to reduce the burden of provisioning VLANs on switches. Vtp can propagate VLAN changes to all the switches that participate in the same Vtp domain. There are four roles in the Vtp architecture. Server. The server switch is responsible for the creation, modification, and deletion of VLANs within the Vtp domain. Vtp servers advertise their VLAN configuration with other switches based on advertisements received over trunk links. Vtp server is the default mode in versions 1 and 2. Client. The client switch receives Vtp advertisements and modifies the VLANs on that switch. VLANs cannot be configured locally on a Vtp client. Transparent. Vtp transparent switches receive and forward Vtp advertisements for switches in the Vtp domain, but do not modify the local VLAN database. VLANs are configured only locally. Off. A switch does not participate in Vtp advertisements and does not forward them out of any ports either. VLANs are configured only locally. Vtp off is only available on switches that support Vtp version 3. However, the switch does not need to be configured to version 3 to use the off mode. There are three versions of Vtp. Version 1 is the default version of Vtp. It does not propagate VLANs beyond 1005. Version 1 supports having multiple servers in the Vtp domain, and the default mode on a switch is server. Version 2, very similar to version 1, does not propagate VLANs beyond 1005. It supports having multiple servers in the Vtp domain, and the default mode on a switch is server. Version 3 allows for the full range of VLANs, 1 to 4094, to be propagated. Version 3 allows for one primary server, and only the primary server can add, remove, or rename VLANs. The default mode on version 3 is secondary server. The primary server role is removed when another switch attempts to become the primary, or the current primary server is reloaded. Version 3 can hide the Vtp password. Version 3 has the ability to transport multiple spanning tree database. Version 3 is backwards compatible with Vtp version 2 for normal ranged VLANs. A Vtp domain consists of trunked switches that are under the same administrative control, sharing the same Vtp domain. A switch can only be in one Vtp domain, and VLAN database contents in the domain are globally synchronized. A password can be set for the Vtp domain to ensure unauthorized switches do not make changes to the VLAN database. Vtp advertises updates by using a multicast address across the trunk links for all advertising updates to all switches in the Vtp domain. There are three main types of advertisements. Summary. This advertisement occurs every 300 seconds or when a VLAN is added, removed, or changed. It includes the Vtp version, domain, configuration revision number, and timestamp. Subset. This advertisement occurs after a VLAN configuration change occurs. It contains all the relevant information for the switches to make changes to the VLANs on them. Client request. This advertisement is a request by a client to receive the more detailed subset advertisement. Typically, this occurs when a switch with a lower revision number joins the Vtp domain and observes a summary advertisement with a higher revision number than it has stored locally. Vtp uses a revision number to propagate changes through the domain. The configuration revision number is compared amongst VTP version 1 or VTP version 2 switches. The VLAN database from the switch with the highest revision number is adopted by all the other switches in the VLAN management domain. Every time VLAN information is modified and saved in the VLAN database, the revision number is increased by 1 when the user exits from the VLAN configuration mode. If you add 2 VLANs, the revision number would increase by 2. In the first part of this lab, we will set up the network topology and configure basic settings and trunks for VLANs. I've saved the configuration in a text file and uploaded it to my website, digitalspiffy.com. You can find the link to download this and other related files in the description below. If you are working in this lab on something other than iOS XE based switches, you will run into a few issues creating some of the VLANs in VTP version 1 and 2. This is why I'm using GNS3. I'll start with configuring the D1 switch. On the D1 switch, I'll configure the host name, enable CDP globally, set the spanning tree mode to rapid pure VLAN spanning tree, configure the line console to prevent timeout, and keep the output from displaying over our terminal. Now I can configure the trunk ports that connect to the other switches. I'll make sure that CDP is enabled. This is something you only have to do in GNS3. If you're doing physical equipment, you won't have to use that command. And then I'll just give the port no shut, make sure it's up. The D2 and A1 switches will start off with the same configuration, and I'll just copy and paste that from my configuration file. And we can do a show CDP neighbor and make sure that these switches are receiving that info from each other. In this lab, we will set up and observe the operation of VTP version 2 and version 3. I'll run the show Vtp Status command on D1 to observe the current VTP setup. No VLAN configuration has been done, and VTP is running the default version 1. The number of existing VLANs is the built-in 5 on Cisco switches. Configuration revision number is 0. I'll configure D1 to operate in the VTP server mode and set the VTP domain name and VTP version to 2. I'll also set a VTP password, and because this password is set, the VTP version will not allow other switches to automatically learn the domain name. So VTP setup, I'll create VLAN 2 and name it I'll assign that to gigabit port 33, and then we can verify our VTP status again. And you'll notice that the revision number has changed along with the number of existing VLANs. And I can run the show VLAN brief command you'll see that the VLAN is assigned to the port that we assigned it to. On D1, I'll create another VLAN. This one will be out of the normal VLAN range. If you are using physical gear, this may be where you run into some issues. So on D1, I'll create VLAN 2048. And now I'm going to verify on D2 and A1 that they have not learned about VLAN 2 or 2048 using the show VLAN brief command. And this is just default config on these switches, so they're not participating in VTP at this time. So now I'll configure D2 and A1 with the same VTP settings as D1. And I'll bounce the ports that connect D2 to A1 to force that update instead of waiting for that to happen. So do an interface range gigabit 101-1. So we'll do a show Vtp status. This revision number should be the same. Let's see why it's not. Just got to give it enough time, and that revision number should increase. So you'll notice that the VLAN 2048 is not going to be on these switches. And that's because the VTP version 2 does not propagate VLANs beyond the normal range of 1005. So you can run this show VTP status and pipe the include VLANs and revision, and you can kind of narrow that output a little bit to just what we're looking at. To demonstrate the main drawback of VTP, on A1 I'll remove VLAN 2. And I'll check that revision number again. You'll see that it's increased to 3. So if we go to D1 and D2 and see if VLAN 2 still exists, you'll see that that is actually gone. So keep in mind that VTP can remove VLANs. If you added a switch to your network and it already had that VTP domain configured, you could override existing VLAN databases, because on VTP version 2, only the configuration revision number is compared instead of the client or server mode. On D1, I'll recreate the VLAN 2 and name it. Let's verify the VTP status. So you can see that revision number has changed. It's at 4. And let's see if the VLAN appears back in the database. So you'll see that the port config is actually back for VLAN 2. On A1, I'll change the VTP mode to client. and I'll attempt to create VLAN 3. You can see from this output that's not allowed in the client mode. And although it prevented me from creating VLAN 3, a switch in client mode can still overwrite the VLAN database because of the revision number. So if that revision number is higher and I had added this switch to the network, if it didn't have VLANs that were already on D1 and D2, those VLANs would actually be erased. So keep that in mind when you're using VTP and adding switches into the network that already have a VTP domain configured. On D2, I'll change the VTP mode to transparent. And attempt to create VLAN 3. And that allowed that to happen. That's because transparent mode allows VLANs to be created locally. So I'll just do this again, create VLAN 1111, name it quad 1, and you'll see in the VLAN database that these VLANs do exist. So we can check D1 and A1 for these VLANs, and you'll notice that has not propagated to these switches. VTP transparent switches keep themselves in the VTP domain, but do not learn or propagate VLAN information with other switches. On D1, I'll verify the Vtp status. So now I'm going to check these ports that connect to A1. So on the D1 switch, I'm going to shut down the ports that connect to the D1 switch. And I'm going to create VLAN 4 and name it. I'll verify that the VLAN database and the VTP configuration have changed. So it's incremented by 1. See if that's in the VLAN database. VLAN 4 is in our VLAN database. So we can check D2 and A1 for VLAN 4. And you'll see on D2 that it's not there, but on A1 it is. So remember that the ports connecting to A1 from D1 are shut. So D1 sent the VTP message to D2, which forwarded the VTP message to A1 because they share the same VTP domain. Also remember that D2 is in transparent mode, so it forwarded that update, but it did not process the VLAN change itself. In this next part of the lab, I'll implement VTP version 3 to operate across the rest of the switches in the network. VTP version 3 provides a few benefits over VTP version 2. It has the primary server ability that keeps VTP switches from being a server and changing VLANs. By default, in VTP version 3, a switch will be a secondary server and must be statically set to primary before you are able to make any VLAN changes. VTP version 3 also encrypts the VTP password, where versions 1 and 2 has the password in plain text. VTP version 3 can propagate information about extended range VLANs, and it's also backwards compatible with version 2 for normal range VLANs. So on D1, I'll configure the VTP primary. So right now you can see that there's no primary. And actually this is done from the exec privilege mode. Oh, and that's right, I need to set the VTP version to 3 first. So you can see right now VTP primary is all zeros. I'll set up that VTP primary. And it will take a second to do that. So you can see the MAC address on that has changed, and that is the MAC address for D1. So checking our revision number here, you can see that it's currently 1. So I'm going to get in there and create VLANs 6 through 11 and name them. And I'm just going to copy that so it doesn't take too long here. We're going to do our show command to make sure that's actually in the VLAN database. So they are in there and they're active. Show our revision numbers increased only by 2. That should be changed. So if we go in there and change the names, and we show our revision number again, it's increased. So on A1, checking the revision number and the VLAN database, you'll see that this hasn't propagated to the switch yet. So this is because my revision number on D1 is 4 and on A1 it's 7. So I got to get that to be matching or higher on the D1 switch. So I'm just going to go in here and change some VLAN names. There we go, finally getting it to increment a little bit. One more change should be matching. So we're already getting messages on that the revision number is not the same. Now it should be, if we check revision number here. Try this in one last time. There we go. So now you'll see, as soon as they matched, it propagated those VLANs. And remember, D1 is Vtp version 3, A1 is Vtp version 2. It is backwards compatible, but it's still Vtp version 2 messages are sent, and the Vtp version 3 messages are just discarded by A1. So until that revision number matched, it didn't propagate that information. On D1, I'm going to create another extended range VLAN. So I'll do VLAN 2600, name it hacker pub, and we can verify the revision number has increased. So it was 8, now it's 9 with that VLAN change. And on A1, we're going to see if that is actually propagated. And you'll see that it hasn't, and it's because Vtp version 2 doesn't support extended range VLANs. So again, just keep that in mind. I'll configure D2 and A1 with Vtp version 3, and then we can verify that their behavior as transparent and client configured switches is working correctly. I'll check the revision number on A1, and you can see here that A1 is now on Vtp version 3. Our extended VLAN ranges have been propagated to A1. So we can do the same thing in D2, and you'll notice that it does not have those VLAN changes in its VLAN database. And again, that's because D2 is running that VTP transparent mode. Thank you for watching the Digital Spiffy YouTube channel. This video is the 5th in a series covering the material on the CCNP ENCOR exam. In this video, we explored the VLAN trunking protocol.